There are places in the universe where the laws of physics break down. Not bend, not stretch, but break, stop working, cease to apply. Places where space itself curves so completely that nothing, not matter, not energy, not even light, can ever escape. We call them black holes, and they are, without question, among the most extraordinary and unsettling objects in the known universe. Tonight, we are going to sit quietly with the mystery of black holes, not with equations or complex mathematics, but with wonder. Because black holes are not just extreme physics, they are philosophical challenges. They ask us questions about the nature of space, the nature of time, the nature of information itself that we do not yet know how to answer. So let yourself settle, let your breathing slow, and let us begin. A black hole is a region of space where gravity has become so intense that nothing can escape it. At the center of a black hole is what physicists call a singularity, a point where density becomes infinite, where the curvature of space becomes infinite, where our mathematical descriptions of reality produce answers that make no physical sense whatsoever. In other words, the singularity is a place where our understanding of the universe runs out, where the map ends and the territory becomes something we have no words for. Surrounding the singularity is a boundary called the event horizon, the point of no return. Cross the event horizon and you cannot come back, not because of any physical barrier, but simply because of the geometry of space around a black hole. Every possible path forward leads inward. There is no direction that leads out. When a star of sufficient mass exhausts its nuclear fuel, the outward pressure that has kept it from collapsing disappears. The core collapses catastrophically, and if the mass is great enough, a singularity forms and a black hole is born. These are called stellar mass black holes. But there is another class of black hole that dwarfs these entirely. Supermassive black holes, found at the centers of most large galaxies, including our own Milky Way, can have masses of millions or even billions of times the mass of our Sun. The supermassive black hole at the center of our galaxy, known as Sagittarius A star, has a mass of approximately 4 million suns. It sits at the heart of our galaxy, quietly, just 26,000 light-years from where you are lying right now. Quietly, and largely harmlessly, it simply exists, turning slowly in the dark. For most of the history of science, black holes were purely theoretical objects. Predicted by Einstein's general theory of relativity in 1915, they existed in equations and in the minds of physicists long before there was any direct observational evidence that they were real. The name itself came later. It was coined by the physicist John Wheeler in 1967, a name so perfectly evocative that it immediately replaced the dry technical descriptions that had come before. And then, in April 2019, something extraordinary happened. A team of scientists using a network of radio telescopes spread across the entire planet, functioning together as a single telescope the size of the Earth, captured the first ever direct image of a black hole. The image showed a bright ring of superheated gas surrounding a dark central shadow, the event horizon, the edge of nothing. Scientists and non-scientists alike were moved by it. A thing that had existed only in mathematics for over a century was suddenly, undeniably, visibly real. We had seen the unseeable. One of the most extraordinary things about black holes is what they do to time. According to Einstein's general theory of relativity, gravity affects time. The stronger the gravitational field, the slower time passes. This is a measurable physical reality. Near a black hole, this effect becomes extreme. Imagine watching someone fall toward the event horizon from a safe distance. As they approach it, you would see them slow down. Their movements would become more and more sluggish, and as they reached the event horizon, they would appear to freeze, suspended at the edge of the black hole forever, from your perspective. From their perspective, however, they would cross the event horizon in a fraction of a second. They would notice nothing special at the moment of crossing, just a point in space that, once passed, cannot be unpassed. Two perspectives, two completely different experiences of the same event, both equally valid, both equally true. In 1974, the physicist Stephen Hawking showed that black holes are not completely black. They emit a very faint radiation, caused by quantum effects near the event horizon. This radiation carries energy away from the black hole. Over an extraordinarily long period of time, a black hole would evaporate completely. This raises a question known as the black hole information paradox, one of the deepest unsolved problems in theoretical physics. It sits at the intersection of quantum mechanics and general relativity, two theories that together explain virtually everything we know about the universe, but which are fundamentally incompatible with each other. The black hole is where these two great theories of physics collide. People sometimes ask what it would be like to fall into a black hole. For a supermassive black hole, you could cross the event horizon without noticing anything unusual at all. You would simply be inside, with no way out, drifting, perhaps peacefully, toward a singularity you could not see and could not avoid. There is something strangely contemplative about that image, the idea of crossing a threshold so profound, so absolute, and feeling nothing. How many thresholds in our own lives do we cross without knowing? How many points of no return do we pass through before we realize that the world on the other side is different from the one we left? We have spent time tonight with some of the most extreme objects in the universe. Objects that bend time, that trap light, that hold at their centers a mathematical impossibility that our best theories cannot describe. Black holes are a reminder that the universe is not fully understood, that beneath the extraordinary success of modern physics, there remain depths of mystery that we have barely begun to plumb. There is something comforting about that, strangely. The universe is bigger and stranger and more full of wonder than we can currently comprehend. Somewhere in the darkness between the stars, right now, black holes are turning slowly, pulling light inward, bending time around themselves, holding their secrets. And here you are, a small arrangement of atoms on a small planet orbiting a small star, lying in the dark, thinking about the darkest things in the universe. That is remarkable, truly remarkable. Let your thoughts grow quiet now. Let the darkness behind your eyes be gentle and warm rather than vast and cold. You are safe. You are resting. And the universe in all its impossible strangeness is holding you gently. Good night.